Chapter 2, Written in the Rocks. Fossil record. The fossil record is tangible historical evidence for evolution. Discovering, extracting, preparing fossils takes a lot of time and is expensive and risky. Fossils are very valuable because without these historical artifacts, we have no proof of evolution. How fossils are formed. The remains of animals or plants find their way into the bottom of the ocean, then are covered by sediment so that they don't decay or get scattered by scavengers, and the hard parts of the fossils are replaced by dissolved minerals. Fossils are rare because they have to survive endless shifting, folding, heating, and crushing of the Earth's crust after being formed. The fossils then have to be discovered, buried deep into the earth. They can only be found when they are raised by the erosion of wind or rain. Only 1% of total estimated number of species to have lived on Earth have been discovered. Radioisotopes. In some igneous rocks, there are certain radioactive elements called radioisotopes. Radioisotopes gradually decay into another element at a constant rate, expressed as half-life, which is the time required for half the isotope to disappear. If we know the half-life and how much remains, it's easy to estimate the age of the rock. In the graph shown is an example of a carbon-14 isotope. 50% of the starting amount is the half-life. Big patterns. In the fossil record showing first appearance of various forms of life that arose since the Earth formed from bottom to top. The first organism arose around 3.5 billion years ago.
Fossilized evolution and speciation. To show gradual evolutionary change within a single lineage, you need a good succession of sediments and without any missing layers, which represents a jump. For example, the Globirulia conoidea, a marine foraminiferan, creates more chambers as it grows. This shows the change in traits over time. Another example is a trilobites, which is an arthropod and is in the same group as insects and spiders. These are more complex marine foraminiferans. As shown on the chart to the right, each year that passes by, there's a gradual change. There is no jump shown in this graph. Missing links. According to evolutionary theory, for every two species, there was once a single species that was the ancestor of both. We call this the missing link. Biologists assumed from anatomical evidence that birds were closely related to reptiles. A transitional species is not equivalent to an ancestral species. It is simply showing a mixture of traits from both organisms that lived before and after. Onto the land, from fish to amphibians, a transitional form between fish and amphibians. Most creatures were tetrapods, which are four-footed vertebrates that walked on land. One example is the Tiktaalik rosé, which is a large freshwater fish. In the picture below, you can see the Tiktaalik living in both water and land. Tiktaalik rosé. Tiktaalik has features that make it a direct link between the earlier lobe-finned fish and the later amphibians. Tiktaalik has two traits. They had gills, fins, and scales. Therefore, it was a fish living in water. Also, it had amphibian-like features, with a flattened head, eyes and nostrils which were on top of the head rather than on the sides.
The origin of birds. The first link between birds and reptiles was actually known to Darwin. Birds evolved from early reptiles due to natural selection. Theropods were agile, carnivorous dinosaurs that walked on two legs. Most famous of the transitional forms is the Archaeopteryx lithographica, which is shown on the right. Archaeopteryx has two specific traits, reptilian and bird. Archaeopteryx came from Germany. Archaeopteryx is really more reptile than bird. Archaeopteryx has two reptilian traits and two bird-like traits. The reptilian traits are the reptilian feathers, the long bony tail, claws, separate fingers, and neck. The bird-like traits are the large feather, the opposable big toe, which is used for perching. Later fossils found were the Cinerotosaurus millennia, which is shown on the left. This is a Chinese bird lizard, covered with long, thin feathers so small that they couldn't possibly have helped it fly. The Myalong, which is shown in the middle, is a feathered theropod dinosaur fossilized in a bird-like roosting position, sleeping with its head tucked under its forelimb. On the right shows the four-winged dinosaur, the Microraptor gui. The Microraptor gui has long feathers on both its forelimbs and hind limbs. It's a 30-inch creature which had fully feathered arms and legs, which, when stretched out, were probably used for gliding. Back to the water, the evolution of whales. Whales and their relatives are mammals, and they are warm-blooded. Whales evolved from a species of artiodactyls, which are a group of mammals that have an even number of toes, such as pigs and camels. Recently discovered fossil was called the Indohyes. Indohyes were raccoon-sized animals. Biologists now believe that the closest living relative of whales is the hippopotamus. They were largely aquatic ancestors of whales. What the fossils say? 3 important factors that fossils teach us are the gradual change within lineages, splitting of lineages, and the existence of transitional forms, finding transitional forms that occur in the fossil record, evolutionary change, even of the major sort, nearly always involves remodeling the old into the new.